In this video, we will cover mini-batch gradient descent. It will allow you to train models with more data. Until now, we have been using every sample for gradient descent. In mini-batch gradient descent, we use a few samples at a time for each iteration. It's helpful to think about it as if you are minimizing a mini-cost function or the total loss. When we use all the samples in the dataset, we call it an epoch. Here is epoch 1. Here is epoch 2. When we use all the samples, it's called batch gradient descent, where one iteration equals one epoch. We use a few samples to calculate the cost. It's sometimes referred to as the total loss. Let's use the following boxes to represent the gradient of the total loss at each iteration. Let's do the first epoch. For the first iteration, we use the first two samples. For the second iteration, we use the second two samples. For the third iteration, we use the last two samples. Therefore, with a batch size of 3 to complete one run or epoch through the data, it took 3 iterations. For the second epoch, it will also take 3 iterations. In this case, our batch size is 2. It only takes 2 iterations to complete one epoch. For the second epoch, it also takes 2 iterations. Let's see how we can determine the number of iterations for different batch sizes and epochs. To obtain the number of iterations, we simply divide the number of training examples by the batch size. Let's verify that. For a batch size of 1, we get 6 iterations. We can verify this pictorially. We see for each iteration we use one sample. For a batch size of 2, it takes 3 iterations. We can verify this pictorially. Each iteration uses 2 samples. Finally, for a batch size of 3, it takes 2 iterations. Again, we can verify this pictorially. We calculate the total loss before each iteration. It's a noisy version of the cost. At the end of each epoch, we calculate the accuracy on the validation data. We repeat the process for the next iteration. If the accuracy decreases, we have trained too much. This is called overfitting. We will talk about this later.